So do know that this is in the previous video. I know that I'm just kind of introducing this. So this is going to be starting to draw some of these covalently bonded molecules. So covalent bond is the sharing of electrons between two atoms. So for this video, you are going to need, again, a periodic table to look at so that you know how many valence electrons that you are dealing with. And these are, again, going to be molecular compounds. So we're going to be drawing these Lewis dot or electron dot structures to show a sharing of electrons. So we first need some definitions of what a covalent bond is, essentially. We are going to have three different kinds of bonds. Single is going to be the most common. Then we might have some double and we might have some triple bonds. We typically have just single bonds. But in all of covalent bonds, you can have double and triple bonds. So single bonds is the sharing of one pair of electrons between two atoms. Again, it'll become more apparent exactly what that is. So again, a pair is two electrons being shared between the two. Double bond is the sharing of two pairs of electrons. So that means a total of 4 electrons are in that bond. And then finally, we have something called a triple bond, and that is the sharing of 3 pairs of electrons or 6 electrons. So we are going to be drawing what we call lines in chemistry. A line in chemistry is equal to 2 electrons. So if you see a double bond, that's going to be 2 lines. If you see a triple bond, that's going to be 3 lines. But typically, again, in our this year is going to be single bonds. If you want to get into more in double and triple bonds, you kind of need to get into what we call organic chemistry, which is carbon-based molecules. So I always start the process of doing these bonds, okay, doing the different bonds and drawing some of these structures, is I always start with what we call the 7 diatomic atoms. They are molecules, actually. They're not, I should not call them atoms. So we have 7 diatomic molecules. These are atoms that cannot exist by themselves. We've learned them before, okay? And we did them especially in the beginning when we were writing out some equations. We haven't talked about them in a while. But do you remember what the 7 diatomics are? So the key is the number 7. So if you find number 7 on your periodic table, that's nitrogen. So if you make the number 7, it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine is the way I remember them. And then there's one that is not in that grouping, and that is our friend hydrogen. So if you remember the number 7 and you start at nitrogen and you essentially make your halogens and your nitrogen, oxygen as a 7, then the only other one you need to concern yourself with is hydrogen. So again, when we were writing these a long time ago, you didn't know quite what to make out of them. But I always start the process with our diatomics and how to draw some of these Lewis dot structure and show a covalent bond. So I'm going to start with hydrogen as my example. So hydrogen is in that first column. And the reason it is in that first column on the periodic table is because there's 1 valence electron. It is an S1. It is only 1 electron that we're dealing with hydrogen. So if I were to have hydrogen and draw its Lewis dot structure, I would draw it like this. And it doesn't matter which side you start on. I'm starting on that side for a reason. If I have another hydrogen that has 1 valence electron, what it can do is essentially get close enough, and your online book does do a kind of a description of 2 hydrogens coming together. And once they get to a certain distance, you actually make the bond. So I could draw it as 2 dots being shared between them, or I could draw a line between them. And again, a line in chemistry means 2 electrons. So again, you're going to find, depending upon what you like to do, if you like to do dots or if you like to do lines, but that is showing essentially a bond. Okay, so this is what we call a single bond, a single covalent bond. Okay, much more complicated ones are going to be the other ones. Okay, so let's look at chlorine, for instance. And remember, chlorine has 7 valence electrons. So I'm going to draw 7 valence electrons around 1 chlorine. Okay, 7 valence electrons around 1 chlorine. And then I'm going to do a neighboring chlorine. I'm going to put them as X's so we could see them as different electrons. Okay, and so the this chlorine on the left needs one more electron. This chlorine needs one more electron, and then it would complete its octet. So it makes a bond between the two. So you can put them as dots between them, or you can do lines to show the bond. And to kind of clarify this a little bit more, this chlorine here now has the magic 8. It has 8 valence electrons around it. And if I look at this chlorine, it now has 8 valence electrons as well. Okay, so since they are sharing these 2 electrons between them, they have completed their octet. And so that is truly what the bond is that sharing of those 2 electrons. So those electrons are not devoted to one chlorine or another, it's devoted to the bond itself. So these are what we call, in the middle is called a shared pair of electrons. Makes sense, you're sharing them. And then anything around it, okay, and I'm going to draw them as lines instead of dots. And again, this is all a personal preference of what you like to do. So you could do like a combination of dots and lines. The electrons that are not involved with the bond but are still attached to the chlorine are called lone pairs. So they're lone pairs of electrons. So they're going to play a role in when we're talking about something called shapes. So shared is going to be, again, the bond itself, and then anything that is around the outside of the atom or anything having to do with it. It doesn't necessarily have to be outside, but if it's not involved in the bond itself, it's considered a lone pair. It's considered a lone pair. So most of the halogens are kind of bonded that way. So I'm not going to draw any more of those. You're going to get some practice with that. So instead, I'm going to jump to oxygen. Oxygen O2. And this is one theory, and there's some issues with how I'm drawing this, but we're just going to kind of play along for the fun of it. So oxygen has, I should draw it correctly, has 6 valence electrons. Has 6 valence electrons. So what does it want to do? It wants to complete its octet. So if I just shared these 2 electrons, I'm still not going to complete the octet. So I still have 2 other electrons I need to share. So I always do this just because I think it's funny. I'm essentially connecting those 2 electrons together and connecting that. And can you actually see this kind of as a face? I don't know if you know, but you know, your brain usually tries to make everything in the world a face. So this is essentially a double bond between those 2 oxygens. So I'm sharing a total of 4 electrons. And again, if you want to do double bonds as dots, you could do that. You could do it as lines. But again, a double bond is going to be sharing 4 electrons. Then, last one I'm going to draw here is nitrogen, N2. So if I draw this, it has 5 valence electrons. So if I put 2 nitrogens next to each other, I'm going to see that I can essentially connect these 3 that are by themselves. So I have two electrons that are a lone pair that are paired up, but I have 3 electrons that are not. So again, this kind of looks like a face. So nitrogen is going to make what we call a triple bond. So a triple bond is going to be 6 valence electrons being shared. Again, it's much easier to do lines between them than to do all of the dots, but you could do a mixture of both. You could always do the bond itself as lines and then do the lone pairs around it. It really doesn't matter. All chemists understand what that means. So again, this is the shared pair between them. So now you have 3 shared pairs, and then you have only 1 lone pair on each one of the nitrogens. So please keep in mind, just like before, okay, I have completed the octet for the oxygen. I have completed the octet for the nitrogens. It just so happens that they are sharing more electrons than they have on their own. So that's the only difference there.